This is MSE 5033 Composite Materials Lecture 10. Um, and this is the first lecture after the spring break. Hope you guys had a good spring break. Okay, I just want to give you a few pointers about the homework on composite analysis. So what I would recommend is that you choose some arbitrary maximum strain failure criterion. So in epsilon x and in the x and y directions, and use the on-axis strains and conclude which ply would fail. So what you would do is what you would get is the first ply failure. When does first ply failure happen? So you may be able to figure that out using this. And then the composite analysis, uh, you can get the in-plane modulus directly by applying the rule of mixtures to the modulus of the unidirectional composite. And the in-plane compliance is the inverse of the in-plane modulus. And if you require the engineering constants, then they can be obtained from the components of the in-plane compliance. So from that matrix structure, you just put them in there and you should be able to get those numbers. And the um, process described so far is pretty straightforward, and it is applicable to flexural stiffness of laminated composites as well. Okay, and you need to do matrix inversion in order to get the components of the compliance from those of the modulus. And when you do that, you can what you will see is that all the components of the modulus participate in the determination of each component of the compliance. So it is difficult to visualize the impact of a change in the modulus to the change in compliance. What you will see is that when you do the analysis, the stress strain relations are pretty analogous to those of unidirectional composites. And if you have in-plane modulus, it is bounded by the modulus of the constituent plies. But the compliance and associated engineering constants are not always bounded by those of the constituent plies. I hope I'm not confusing you guys, but what you will see is that the in-plane modulus is pretty straightforward, but the compliance is not straightforward. And when those constants are not bounded, are not clearly defined, then it is very difficult to rely on intuition. So you may not understand what those numbers really mean. Okay. And one thing to note is that you must keep track of the signs. You must know how the properties of the constituent plies are translated into the stiffness of a composite. And the components of the modulus are preferred because the variations with the ply properties and stacking sequence are governed by simple, explicit linear relationships. Okay, so now switching gears a little bit, I'm going to talk a little bit about when you make a component, what is the first thing you have to do? You have to inspect it. And once you inspect it, you have to know whether something is acceptable or not. And I'm going to talk about this more from the point of view of aerospace composites, because aerospace composites is the area where composites are used the maximum. So you want to know how these things are done in that field, because that is the field that is the most advanced. Okay, so how do you know if your component is conforming to the requirements or not? And the first thing to note is that it depends upon whether the part is made for military applications or for commercial applications. And The military handbook is controlled for the Department of Defense, and the commercial is defined by customer. But it may all, I mean, if it is for aerospace, like Boeing or Airbus, those may be more stringent than the Department of Defense. What is the one of the most common things that we do? We want to see. We said, hey, this should be 1 feet by 3 feet by 1/16th of an inch thick. So most of the time you are going to be looking at dimensional conformance, whether it is within tolerances as defined on the product drawing or not. And the structural conformance, like the strength, modulus, shear strength, interlaminar strength, etc., they are all defined by the acceptance criteria that is defined by the customer. And especially if you have ISO and ASO regulations, then it is important to have written acceptance criteria. And these are mostly defined by the customer or the supplier. These are also organized by basic structural configurations. So laminates, sandwich panels, bonded laminates, etc. And when you inspect it and when you see a defect, then you have to make sure that you write them down properly. So what is the imperfection name? What is the description? What is the inspection method that you used? What is the acceptance criteria, whether something is acceptable or not, and whether that defect is primary or non-primary. And you write all that down and make sure that the different types of defects are described properly um, in the written document. So you probably know what is called, I mean, like Alex probably knows what is the traveler. So when you make a component, you send something along with this complete document, and that is called a traveler. I hope that is correct. So, and if a component is not conforming to the requirements, then it is non-conforming and you reject that part. And you need to dispose it off in accordance with standard repair procedure or by MRB engineering. And so you can reject it by several, I mean, like, you can scrap it, you can rework it or repair it. So what are the inspection criteria? You can control the material and you can control the process. What are the methods of compliance? And so where all do you look at? I mean, like, you have to look at the raw material suppliers, and you have to look at the OEM people who are fabricating the parts. And if you have subcontractors or partner fabricated parts, you have to look into that also. So all of that needs to be taken into account when you are inspecting and accepting the part. So which are the steps that require control? So you can control the material, you need to control the tooling, because before you make the component you have to prepare the tool and you have to clean the tool, and all those processes need to be recorded and make sure that it is within compliance. Then the next and most important step is you have to lay up the part, and then you have to make the part. You may have to do some machining prior to curing. Then you cure it, compact it, and um, then you inspect it. So when you are looking at the component itself, I mean, if it is a commercial program, you have what is called CFRs, which are called the Code of Federal Regulations. And If it is military, then they have their own system design specifications. So, you may see that per Bell SPI 431, which means that Bell helicopter will fully comply with applicable regulations. And or if it is under FAA regulation, I mean, even if you're repairing it, or even if you're replacing a component, you have to make sure that uh, you will have an approved production inspection system that will ensure that each product will conform to the type design. So the MRB has got these CFR regulations. And for example, you would say incoming materials used in the finished product must be as specified in the type design data. So it should have the properties in order that you get the right kind of component design specs. So, for example, if you have this particular CFR document, you have to maintain the quality control system in conformity with the data and procedures approved for the production certificate. So only if you meet those requirements, then only you will get the production certificate. Okay, so and these are some of the specifications, and these are the design values. So you have statistical basis for that, and you also have the number of samples to be tested and things like that for each of those. So this testing procedure is taken as a building block. So you would make coupons and you would test them, and only if it meets those design specs, then only you make these elements and test them. Then you would inspect the dimensions, etc. Then you look at the subcomponents, and finally you would test, inspect and test the full component itself. Okay, so you always start at the base and then you build it up to the component level. What are the methods of compliance that you have to use? You have to inspect the composite parts and assemblies, and most of the time you have to inspect the first article to demonstrate that all the engineering requirements are met. Okay, so it will make sure that the production configuration, materials, processes, tooling and inspection are all met, and you create a baseline conformity data set. And then you also have non-destructive and destructive testing procedures set in there, and it has to be followed religiously. There is no ifs and buts, because you are dealing with lives, people's lives. So you have to make sure that the component properties are met. So what are the different types of inspection that you would do? You would do the inspection during production. You would do the inspection after production also. So the NDI is formalized, and it is a written inspection procedure and acceptance criteria, and it can be general, and it can also be part specific. And if it is a primary dynamic loading type of a structure, then you may need some kind of a destructive test in order to make sure that it meets the first article meets the requirements. And you may also want to have some kind of an unscheduled destructive test. Suppose you are making 1,000 components. What do? You would test it at different intervals, but you also may pull out one component out of 1,000 at random and test it. and make sure that it meets the standards. So those are all the different methods of compliance. And there is something called material review board that is established at each um, vendor or the final component final system manufacturer, and they get together and they are required to assess and dispose of all non-conforming materials and parts. And these are very specific requirements, and it is formalized. You cannot say, hey, please let this go. You cannot do that. You have to make sure that it meets the standard. Okay, and this process also needs a periodic audit. So if you are in the production line, you will have to take time off in order to sit down with this MRB board and make sure that your system, processes, materials, everything is conforming to the requirements. And because this becomes a very standardized process, so if you have an ISO standard, ISO 9100 or ASO 9100, you have to make sure that your standards are meeting all the requirements. So if you automate the process, then you can reduce the process variability. So for example, if it is the fiber placement process, so your materials are pretty standard and this process is also pretty standard. Or if you have 5-axis machining, or it's called if you are doing water jet cutting, drilling holes and things like that, those processes are pretty standard. So then you need to you have less process variability. Of course, you have to do the testing according to the requirements, but those requirements might be less stringent if you were to do it all by hand. If you were manufacturing something by hand, then your inspection process also gets extremely stringent. So when you get all these results, how do you integrate them? It's a pretty big challenge. Okay, so you have to establish and monitor the manufacturing and processing controls across an extended supply chain. So if you are getting components made by 10 different people or 100 different people, you have to make sure that everything is inspected according to the requirements. Okay, so and if you test it, and if the material supplier also tests it, he says this has a strength of 100 ksi and you end up with 200 ksi, or you end up with 50 ksi, who are you going to believe? You have to make sure that the test methods are uniform between the supplier and the end user or the subcontractors. So you have to make sure that there are no lab to lab variation. So you have to make sure that everything is standardized. So, and you have to interpret the results in a very consistent manner, which means that everybody needs to be trained using the process under the same methods. And you need to be trained and retrained from time to time. And suppose you are making a component, say in Japan, and you are accepting and finally assembling in South Carolina, you have to make sure, you have to account for the, and you have to understand and address the cultural differences. You have to make sure that everything is uniform. And the other thing is that if it is an international, if there are international programs, you have to make sure that the international trade ITAR requirements are met and addressed properly. So there is an oversight board, there is an auditing board, and there is an MRB board. All of those, there could be people, sometimes, in order to make sure that something, there is no bias in it, So the people sitting in one board are probably not going to be in the other board, and so on. So the mill handbook is pretty standard. You can find that at this place, so you can go and download that and see what that handbook is all about. Okay, so let me stop here. I will load up the next part of the lecture in the next lecture.